Hello everyone, and welcome to the Introduction to Research Methods in Psychology, Module 5. Today's topic is experimental research. Experiment is a type of study design that being used to answer the question if there is a causal relationship between independent and dependent variable. When we say causal relationships, we mean that changes in one variable, called independent variable, cause changes in another variable, called dependent variable. Why dependent variable called dependent? Because it depends on changes in independent variable. In experiment, a researcher systematically varies the level of independent variable. The different levels of independent variable called conditions. Let's reuse an old example from another lecture. Let's imagine that we would like to conduct a study about how the time of the study, whether it's in the morning, during the daytime, or in the evening, influences study results. In this case, we can ask 3 groups of students to study either at the morning, during the daytime, and the third group will study only during the evening time. The time when the students were studying are conditions. So in our study, we have 3 conditions: studying at the morning, studying during the daytime, and studying at the evening. As a dependent variable, we can choose students' grades in a standardized test. But there are other variables that can influence our results. How about if the students were taking some caffeine to help them study? What about hunger? What about if the students try to eat some sweets to help them thinking? Or where the students were studying? In their home? Or maybe in the library? Or maybe somewhere where it's a little bit noisy, like in the cafe? As a researcher, we would like to control those variables. How can we do that? Well, for example, we can ask the students only to study in the library. In this case, we can be sure that all of them experience the similar amount of the noise and interruptions. We can also ask them not to consume any caffeine or do not eat anything during the studying. Another and more realistic possibility is to just ask students to keep notes where they were studying, how noisy it were, did they have any interruptions, or what did they drink or eat during the studies. The variables we would like to control called extraneous variables. In our example before, we discussed a type of extraneous variables that called noise. There is another type of extraneous variable, confounding variables. A confounding variable is an extraneous variable that differs on average across levels of the independent variable. In our example, that can be IQ level of the students. Let's imagine that our morning students have significantly higher IQ level on average than our daytime or evening students. Or if our morning students all third-year students and our evening students just started their studies, their result at the standardized test or exam can vary a lot. between groups. A confound variable can and should also be controlled. You can either pre-test all the participants on the IQ level and then to allow participants only with a specific IQ level to participate. The second and more realistic approach is random assignment to conditions. Let's speak about special kind of psychological study, a clinical research. In this case, participants would be experiencing some treatment, a training for example. They will be tested before the treatment and after it. To make it less boring, let's imagine that we, as a research group, would like to test our new invention, an anxiety training. To do so, we would like to invite participants. To be sure that confounding variables will not mess our data, we would randomly assign them to a treatment and to a control groups. Both groups will be tested and their anxiety levels on, for example, spiders. After that, the experimental group would receive a new treatment, our new invention, an anti-anxiety training, and the control group would receive nothing. After that, both groups would be tested again on their anxiety level. After that, we can compare anxiety levels in experimental and control groups before and after the treatment. That will help us evaluate if the new treatment is worrisome. But what about placebo? Our experimental group can have improvement in their anxiety level, not because our treatment, but just due to the fact they were treated. In this case, we can test 3 groups: an experimental group, a control group without any treatment, and a placebo group. When we spend, for example, time with our participants, but do no anxiety training. But how ethical it is to test participants and to offer them a placebo but no treatment? There is 2 possibilities how this problem can be solved ethically. The first possibility is the participants from the placebo group and no treatment group will be offered to get the treatment after the testing phase for the experimental group will be over. Or more cheaper version is that the experimental group would be treated and the no treatment group will be just held in the wait list and would be treated after that. Next topic I would like to discuss are different ways to design an experiment. All the experiments from our examples were between subject experiments. A between subject experiment, each subject is being tested only in one condition. It can be more than one condition in these experiments, but each subject can be assigned to only one of them. A different type of the experiment is a within design experiment. In this case, each subject is being tested in all conditions. But let's circle back to the between subject design. Since each subject participates only in one condition, it is very important to control the confounding variables. associated with participants. One possibility we can do it is by random assigning participants to different conditions. There are different approaches we can use by random assignment. For example, we can flip a coin, or more realistically, just use a random number generator to assign a participant. In this case, a blind faith would decide in which condition this participant would participate. Another possibility is a block assignment. In the block randomization, each condition occurs once before repeating. There is another possibility for controlling confounded variable. We can match participants from the experimental group and control group across one dimension. This approach is usually being used in clinical studies. For example, if we would like to test a group of patients with prosopagnosia on their math abilities, you will, with a huge possibility, get patients in different ages and genders. In this case, it will be clever to match subject from a control group on age and gender with the patients from the experimental group. Now let's talk about within subject designs. In this scenario, we do not need to worry about matching our participants in age, IQ level, or personality type, because by participating in all our conditions, our participants are automatically matched. And this is a huge advantage of within subject designs. But sadly, they can result in some unwanted effects. For example, a carryover effect. It is when being tested in one condition affects participant later behavior. A type of carryover effect is a practice effect. It is when participants improve their behavior due to practice. Or a fatigue effect, when the participants perform worse in the later appointment because they get tired or bored. There is a context or contrast effect. It is when stimuli or tasks are perceived differently depending on what came before. Let's use a textbook example to illustrate a context effect. Let's say we asked our participants to judge somebody's attractiveness. If the participants saw in the first block more attractive people, they can judge person from the second block more harshly. Or other way around. If in the first block our participants saw persons who are being less conveniently attractive, they may judge persons from the second block as more attractive. Of course, those effects can be and should be controlled. One possibility is counterbalancing. Let's reuse this example with attractiveness rating. We have 3 blocks of people. The first one is being expected to be highly ranked. The second one is being expected to be ranked somewhere around the middle. And the third block with the people who looks below average. In this case, we should apply counterbalancing, meaning our subject will participate in all conditions, but in different order. In a 3 conditions experiment, we can combine those blocks in 6 different ways. Now let's move to the next topic of our lecture: validity. There are 4 types of validity: internal validity, external validity, construct validity, and statistical validity. An empirical study have high internal validity if the way it was conducted supports the conclusion that the independent variable caused any observed differences in the dependent variable. Non-experimental studies, such as observation studies, are usually low in internal validity. External validity. An empirical study is high in external validity if the way it was conducted supports generalization the results to people and situations beyond those actually studied. We have already discussed that a bit. For example, in the case of developmental studies, our participants are usually from middle class to upper middle class families, are from racial and ethnical majority of the country where the study was conducted, and have no physical or mental disabilities. So our typical participants are pretty different from a typical child. Not only developmental psychology suffers with a lack of external validity, a lot of psychology studies are being conducted on psychology students, who are usually very young, have above average IQ, and are also from middle class families. The question if the result of those studies can be generalized on a typical person who is pretty much different from a first-year psychology student is being discussed a lot. Construct validity. Construct validity of the experiments depends on how well we operationalized our research question. Do the experimental manipulation actually address the research question? Statistical validity. The statistical validity speaks to whether the statistics conducted in the study are sound and support the conclusions that are made.